In this video, we continue our work with logarithms. We want to take time here to notice properties of how logarithms behave. We will do this so that we can transform logarithmic expressions into other forms. As we have seen in other mathematical situations, sometimes writing an expression in an equivalent form does a lot of mathematical work for us, and it will help us, sometimes, to find a solution that we may not otherwise see. Let's look at the three properties of logarithms that our workbook lists. When working in situations where we can use these properties, it can sometimes be tempting to apply these properties in an incorrect way. So to help us guard against that, I want to step through why property 1 works the way that it does, using an example. So, consider log base 2 of 8 times 16. Well, focusing in on just the 8 times 16, we know that this product can be rewritten as 2 to the third power times 2 to the fourth power. That product will be 2 multiplied times itself 3 plus 4 times, or 7 times. So it can be rewritten as 2 to the 7th power. Putting this understanding together with the initial logarithmic expression that we were given, and we can see that log base 2 of 8 times 16 will equal log base 2 of 2 to the third power times 2 to the fourth power. We know that that equals log base 2 of 2 raised to the 3 plus 4 power, and that equals log base 2 of 2 to the 7th power. But we have enough experience with logarithms now to see that this expression, log base 2 of 2 to the 7th power, equals 7, because the power I must raise 2 to in order to obtain 2 raised to the 7th power is 7. So, looking at the structure of this problem, we see that the problem kind of amounts to adding 3 plus 4. However, looking closely, we notice that we aren't just adding because we just want to. We add because logarithms are the inverse functions of exponential functions. And when we simplify exponential functions that have like bases, then we add their exponents. And that is exactly why the expression equals 3 plus 4 in this problem. Now, for those of you who are observant, you might see how we can express 3 and 4 using logarithmic notation in this problem to arrive at 7 as an answer. Note that log base 2 of 8 equals 3 and log base 2 of 16 equals 4. So working strictly with logarithmic expressions and noticing the structure in our first line of reasoning, we can see the reasonableness of property of logarithms number 1, because log base 2 of 8 times 16 equals log base 2 of 8 plus log base 2 of 16, which equals 3 plus 4, and that equals 7. The powerful thing about this property is that if we input a product into a logarithmic function, then the output of the function can be expressed as the sum of two function outputs. Sometimes it is very useful to change a multiplication problem into an addition problem like this. Question 7 in Module 4 Investigation 8 gives you the opportunity to practice working with these properties of logarithms, numbers 1, 2, and 3. As you consider how to simplify the expressions in Question 7, parts A through F, be sure that your logarithmic expression is in the exact form that the property says it must be in before rewriting the expression according to the property. For example, I can say that 3 times the natural log of 17 is equal to the natural log of 17 raised to the third power, because this is the form of property number 3. Also, remember that ln just represents log base e. But I cannot say that log base 5 of 6 times log base 5 of 8 is equal to log base 5 of 6 plus 8. This does not follow the structure of property number 1. In fact, this mistake switches around the operations in the problem. What is multiplication in this mistake should be addition, and what is addition should be multiplication.